All right, for Algebra 2 today, we are doing 6.2 quadratic functions. All right, so today though, our function form, I want you to notice, is different. Okay, so we have f of x equals a times the quantity x minus h squared plus k. All right, so this is called vertex form. So it's a little different than what we've been talking about. So first of all, our objectives. We're going to graph quadratic functions of the form f of x equals a times the quantity x minus h squared plus k by transforming the parent function f of x equals x squared. That's always our parent function. Okay, the second thing, we're going to write quadratic functions in vertex form by completing the square. Okay, so we're going to have to complete the square to do this. 3, we're going to determine the vertex, domain, range, and axis of symmetry of a quadratic function of the form f of x equals ax squared plus bx plus c. And then 4, we're going to solve some real-life applications involving the minimum or the maximum values. So quite a few things on the plate here. Tomorrow, we will probably do a review worksheet or a review day with several worksheets kind of covering 6.1 and 6.2 stuff and making sure we can convert from general quadratic form to vertex form as well. All right, so let's look at this vertex form. Okay, so again, it's f of x equals a. We have this quantity in here. It's important that we realize it's x minus h, okay, squared plus k. Okay, so our h and our k are going to be new things now because our vertex of the parabola is at the point h comma k. Okay, so that's where our vertex is. So if we have it, it's kind of like slope-intercept form. Like once we have an equation in slope-intercept form, if you remember that, right, y equals mx plus b, you could find the slope, you could find the y-intercept, you could graph it. Once we have a quadrilateral or quadratic, pardon me, in vertex form, we can find the vertex. We can also find the axis of symmetry because it's always at that vertex, right? So our axis of symmetry is that vertical line x equals h. Sorry, I had to pause there for a minute and come back. So the other things that we can learn from the vertex form is h, which is our horizontal change. Okay, so if we have our parabola here, we want to know how is it moving side to side. Is it moving left or is it moving right from the parent function? That's what h is going to tell us. So if h is greater than 0, it's going to move, shift, sorry, this is backwards. Let's make some changes. It's going to shift right. Sorry about that. Okay, so this is if it's h is greater than 0, it shifts right. If h is less than 0, it's going to shift left. So make those changes there, please. But h tells us the horizontal shift, where k, okay, in the vertex form, tells us our vertical change or our vertical shift. So if we have our axis here and our parabola, again, centered there, if k is greater than 0, we're going to shift up. So we're going to move our parabola, well, I shouldn't draw it over there. If it's going to move it up, so we might have our parabola here. If k is less than 0, it's going to shift down. So we might have our parabola here, okay, because it shifted down. But we always kind of think about, well, how are they moving in regards or in reference to that parent function that's centered at 0, 0. This one would have been 2, centered at 0, 0. Okay, is it moving to the right? Is it moving to the left? Is it moving up? Is it moving down? Okay, that's what having our equation in vertex form can help us see. So let's actually put this into practice with the next one. So can you get out 2 different colored pens or colored pencils, highlighters, whatever? I've got some colored pencils. I'm looking now. I don't think I have them. I think I gave them back to, I did, give them back to Miss Fountain. But I have some pens, highlighters, whatever you can use. Feel free to borrow anything from me if you need it. But the reason I say this is because I want to highlight a couple different things. One, First of all, we have f of x equals x squared is always our parent function. That's the one we're going to compare it to. And so in this case, it's the one that's dashed. So you wouldn't have to highlight that one if you didn't want to. But the dashed one is our parent function, okay, because it's saying x squared. So if x is 0, 0 squared is 0. If x is 1, 1 squared is still 1. Negative 1 is also 1. You can kind of see that. If x is 2, then we go over to 2, and 2 squared is 4. So there's a point at 2, 4 and negative 2, 4. And there's a point at 3 and 9 and negative 3, 9. Okay, that's that parent function. All right, our next one then is going to be our g of x. Okay, it's the g of x, and it's this one here. If you'll highlight both of those, make them the same color to stand out. So this is your g of x. All right, so just like when solving, okay, if we look at this g of x function, okay, we want to set the function equal to 0 to solve for it. Okay, so if we do that, so if I was solving, I would have to add 2 to both sides. So we get x minus 2 equals 0 when x equals 2. So my x value here is 2, and my y value is the 0 that I set it equal to. Okay, that is going to help me with identifying the h. Okay, my h is my, what did I say? It's going to be my shift, horizontal shift. So this just kind of helps me know where this point is, right? This vertex is h and 0. All right, so if we look at the formula, x minus 2, remember that in our formula we have a times the quantity x minus h squared plus k. So our h value is what? So we have x, we have a minus, so our h is that positive 2, which means we're shifting our parabola which direction? Excellent, we're shifting it right 2 from the parent function. And we can go back and look at that. We were here and we shifted this way and it went 2 places. That's perfect. All right, let's look at the next one. The next one is h of x equals the quantity x plus 3 squared. All right, so that's the other parabola here. That's your h of x. Okay, so if we look at this one, we're going to compare, right? It's supposed to be a times the quantity x minus h squared plus k. Okay, so we have an x, and wait a minute, we don't have a minus, we have a plus. So we need to change this. It'd be the same as minus negative 3, right? Is how we would get that. So then our minus can cancel, and that makes our h value actually a negative 3. Which means we're going to shift our parabola left 3 places, which is exactly what happened. Again, from the parent function, we went left 1, 2, 3 places. Okay, we shifted it left 3. And we just graphed the same parabola. Okay, we just shifted it a little bit. So we start off a little bit basic. We didn't have a k value on these or an a, just looking at the horizontal shift. We're going to add some vertical shift into it and some horizontal and vertical shift as we proceed. All right, so let's keep going. All right, now we're going to get into that with having multiple shifts to it. Okay, so again, we've got our parent function. I'm going to put in orange here. Okay, that's my parent function. And I'm going to compare my p of x. So that's this one right here. It's kind of hard to trace it up here, so I apologize for that. Okay, so now I've got p of x equals the quantity x minus 2 squared minus 3. Again, if we compare this to vertex form, which is a times x minus h squared plus k. What's my value for h? It's a 2. Good. Which shifts it which direction? Left 2. Awesome. What's my value for k this time? Notice, okay, when you're looking, this says -3 and this says plus k. You got to watch out for that. So yeah, here our k is -3. It's a -3. And k is our vertical shift. So is this going to shift it up or down? Excellent. It's going to go down 3. So if we compare that, if I look here, I'm sorry, I put shifts left 2. What on earth? You guys are probably screaming at me, thinking, what are you doing? This should shift it right. It's a good thing I catch my mistakes at least, so you guys don't have to tell me about them when I get back, thankfully. I'm sure I make mistakes I don't catch. But we go right 2 and down 3. And there's our same vertex. And you can do any point, right? If I pick this point up here, that's 3, 9. I go right 2 and down 1, 2, 1, 2, 3. It's still there too. Okay, so I just move every single point. Right 2 and down 3. Right 2 and down 3. All right. Hopefully this is making sense, like just comparing these. Okay, so our next one is going to be r of x. And that's the graph here is our r of x. Okay, so again, we're going to compare it to our vertex form, x minus h squared plus k. All right, so our h value, remember, this one has a minus, this one has a plus. So we're going to have some differences. What is my h value then? Good, it's a -3, which means we're going to shift it, awesome, left this time, 3 places. And what's my k value? This time I have a, right, in my formula it's positive plus k, and I have a +4 here. So what is my k? Good, it is 4. So that's going to shift it up 4, because that's my vertical shift. And again, we can check. So from my parent function here, my vertex, I shift left 3, 1, 2, 3, and I should go up 1, 2, 3, 4. And there is my vertex. Okay. So that vertex form is very, very, very helpful in order to graph your parabola. Okay. Okay, let's try example 3, where you actually get to do some of the work. All right. So it does say to graph, you may need to make a table. That's up to you how you do this. I'm going to show you how to do it without necessarily making the table, but we're going to analyze what we've got. Okay, so first of all, if we want to graph this q of x equals -1/2 x plus 4 squared plus 1. All right, so let's analyze the equation and pick out all the parts. So again, function or vertex form is a times x minus h squared plus k. You guys are probably going to get tired of me writing that, but hopefully it's embedding it in your mind. So our a value is what? Good, -1/2. What's my h value? Perfect, it's going to be a -4, right? Because in the formula we have a minus h, and in the one that we were given we have a plus, so it's going to be a -4. And what's the value of k? It's 1. Oh, sorry. Takes me twice as long to erase. Okay, so it is, k is a 1 because in the formula we have plus k, and in our equation we have plus 1. Awesome. All right, what's our vertex? Remember, our vertex is h comma k. So our vertex is going to be -4 comma 1. Awesome. How about the axis of symmetry? Axis of symmetry. Remember, it's always going through, right? The axis of symmetry is that vertical line through the vertex. So this is going to be x equals -4 is our axis of symmetry. Okay. And on this one, I am going to use a table actually, because there's some more things to look at, because we haven't talked about how to use the a values yet. So we will make a table here to do some of those. So let's see, we've got 1/2 is our denominator. So let's use -3 and 0. Not -3. Let's use -4 because then it'll cancel. All right. All right. So we're going to do an x value. We're going to have -1/2 x plus 4 squared plus 1 in here, and we'll get out our f of x value, or q of x in this case. All right. So I'm going to use -4, -2, and 0. Okay, so we should have our axis of symmetry should come up there. And we'll show you how it does. Okay, so let's see. So we've got -1/2 times -4 plus 4 squared plus 1. Goodness. All right, so -4 plus 4 is 0. 0 squared is 0. -1/2 times 0 is 0. So 0 plus 1 is 1. Sorry, 0 plus 1, yes, is 1. Good. Let's put -2 in there. So we have -1/2 times -2 plus 4 squared plus 1. Okay, if you need to work this out, that's fine. I'm just plugging it in here. So we've got -2 plus 4, okay, squared. So -2 plus 4 is 2 squared. So that's going to be 4. -1/2 times 4 plus 1 is what we need to do now. So -1/2 times 4 is equal to -2 plus 1. -2 plus 1 is -1. All right, and let's try our 0. So -1/2 times the quantity 0 plus 4 squared plus 1. Okay, because I'm just plugging the 0 in for my x. Okay, these are my x's. So let's try that one. 0 plus 4 is 4. So 0 plus 4 is 4. 4 squared is 16. -1/2 times 16 is -8. -8 plus 1 is -7. Okay. And so let's see, we know our vertex, right? Our vertex is at -4, 1. Look at that, -4, 1. We shouldn't have even used that point. Like, we kind of wasted our time solving it because we already had it. But this is a nice way, like, to show you guys, like, that you've done the work here. You wouldn't have to use this one. But I picked numbers that would give me, that were factors of 2 or multiples of 2. So that my 2's would cancel and I get whole numbers. So anyway, let's do this. So we've got -4, 1. 1, 2, 3, 4, and 1. And then -2, -1. So 1, 2, -1. And then 0, -7. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now the cool thing about this, all right, is we know our axis of symmetry is -4. So I'm going to draw my axis of symmetry in there. We don't have to solve any more points. We just have to apply the axis of symmetry. So like this point here, that -2, -1, is 2 places away. Let me see. So right, it's 2 away from our axis of symmetry. So we're going to go 2 away from our axis of symmetry, and we're going to put another point. Here, we're 1, 2, 3, 4 away. Kind of switch colors. So we're going to go 1, 2, 3, 4 away and put our other point. And then we have our parabola. Okay, we have our parabola. So we don't have to, my point here in with the table is you don't have to calculate all of the points. You just have to find a couple, know where your vertex is, find a couple of points, know where your axis of symmetry is, and then you can do a mirror image on the other side of it. Also with this, one other thing, since we have our vertex here, we've talked about the min and the max. Is the vertex a min or a max for this parabola? Awesome, it is a maximum. Okay, so the maximum is at -4, 1. We could say that too, right? Because it's a maximum point. Okay, because this is the biggest number. We're not going any higher than that. So our vertex is a maximum point. Maybe I should write maximum point, however you want to look at that. Wonderful. Okay, now the next thing on our agenda. Sorry, I clicked the wrong button there. The next thing on our agenda is looking to get from general form to vertex form. Okay, so right here, going from general form to vertex form. I told you earlier with some completing the square. So we've got our general form, ax squared plus bx plus c. We want to get it to vertex. A times the quantity x minus h squared plus k. All right, so we have to complete the square with a twist in order to do this. It's kind of crazy, but it's going to work. So we add the b divided by 2 squared that we've always used. Okay, we're going to add that to the quadratic and the linear terms. So if you look down here, I've got my quadratic term because it has the x squared, and I have my linear term because it's just the x. And I have added, we have to add the b divided by 2 squared term to those. That's why it's in parentheses. Okay, so those are in parentheses because I've added it to those terms. Then, this is where it's the twist, we subtract it from the constant term. So remember, c is my constant term. So now I'm going to turn around and subtract it. So I'm going to subtract the b divided by 2 squared. Okay, the reason we do this, okay, is, let me read this. So since we add and subtract the same amount, we are not changing the value of the function at all. I know it's totally weird, it's kind of trippy, but we're not changing the value of the function at all because we add it in the beginning because we want to be able to get this into an x plus or minus some quantity that's squared. We want it in this completing the square form. We have to have this set up, right? We have to have it here. So this would, because that would be our h value, but we've got to get it in that squared form. But then that means, hey, we can just subtract it from the constant and everything will work out fine. Okay, we're not changing the value, but that's the twist that I'm talking about there. Okay, so let's try it. All right, so example 4 says write f of x equals x squared plus 3x plus 1 in vertex form, then state the vertex and compare the function's graph to the graph of f of x equals x squared. So that's our parent function, and it's already on there, right? Saved you some time. Your parent function is already on there. All right, so here we go. This is our function. So we've got x squared plus 3x plus 1. So remember, we want to add the b divided by 2 squared, and then we're also going to subtract the quantity b divided by 2 squared. All right, so let's get to it. Okay, so we're going to have x squared plus 3x plus, what's my b value? It's the 3 here. So this is going to be 3 over 2 squared. All right, plus, well, let me go back. Sorry, change colors here. Plus 1, and now I'm going to subtract it. Minus 3 over 2 squared. I was going to change my colors. What on earth? So you could see a little easier what's going on. It just didn't change on me. So then we're going to subtract the 3 over 2 squared. So we added it to the quadratic and the linear terms, and we subtracted it from the constant term, that 1. Okay, just like previously when we've done squares and completing the square, we can take this down. We're going to make it into that squared term. It's going to be x plus 3 over 2 squared. Hopefully you remember that shortcut. We'll work on it some more. Okay, but it's going to be x plus 3 over 2 squared plus, now we got to do some work on this one. We've got 1 minus 3 over 2 squared is equivalent to 9/4. All right, which means 1 minus 9/4 is what? Right, because 1 would be 4/4, so this is the same thing as 4/4 minus 9/4. Okay, good. So we're going to have x plus 3 over 2 squared plus, but not plus, right? Because you said it was minus. So minus 5/4. All right, so that is our vertex form right there. Okay, so we want to state the vertex. All right, so our vertex, it's not a very beautiful one, is, remember, it's our h comma k, which means our h is, what is my h? It's a negative. Remember, it's the negative 3 over 2, comma, and our k is negative 5/4. Okay, so if you remember, if you're struggling with that, remember it's a times the quantity x minus h squared plus k that we're comparing it to, which is why we have negatives. All right, so our parabola is at negative 3/2, so it'd be negative 3/2, so 1.5, and then negative 5/4. So a little over 1. It's going to be, there's going to be our vertex, like right there. Okay, if we needed to do that. But it says compare the function's graph to the graph of f of x equals x squared. So what can you tell me? You don't even really have to graph it. Or you can graph it, like you can tell me what happens. But if we compare it, how about we compare how it opens? How is this graph going to open? It's going to open up just like the other one. So both open up. That doesn't change. Okay. Has it shifted left or right? Yeah, it shifted left. Did it shift up or down? Good, down. So it shifted left and down. But those are great comparison points, right? If we graphed it, because it would, nothing else changed except moving it left or right. Okay. Now, I think we're actually going to stop there because that's a lot for you guys to take in today. So let me pause this because I don't want to confuse you with the next part when we have an a value. So let me pause it and figure out what I'm going to change your homework assignment to. All right, here we go. I've got it. So I want you to do 1 through 17 odd and number 27, and it's still on page 245. Okay, but those are all have an a value of 1, right? Like it's not there. And then when I come in tomorrow, we'll work on when a is a larger number, or we might have the review. We'll see how it goes. We'll be prepared for both. So have a good night, and enjoy the completing the square with a twist tonight.